Hey learners, this is Dr. Rishi from the Learners Academy, and today we are going to go ahead and solve some numerical examples from the chapter Force. We have done 3 videos on chapter Force and the links have been given in the description box. Today we are just going to solve different examples related to all the topics. I have segregated the examples into 2 parts, the easier ones and the difficult ones. So please pay attention to it. So without losing any time, let's go ahead, and the first example that we are going to do is the solved example where we have the moment of force of 5 newtons. So the force is 5 newtons and the moment of force at point P because of this force 5 newtons is 2 Newton meters. Again, they've written it in a very confusing manner, which they are telling us it is moment of force of 5 newtons. Many students would be reading as the moment of force as 5 newtons and then using that as 5 newtons. It confuses, it's a 2 marker, it confuses and it could cost you marks. So please read the question properly. Now here we have to calculate the distance of the point of application of force. Now we know the formula that the moment of force tau is equal to the force multiplied by the distance. So we can use this formula directly to get the answer for this particular sum. So let us go ahead. Here we have the force is 2, the moment of force is 2 Newton meters and the force is 5 newtons. The formula is moment of force is equal to force multiplied by distance. So we can have it as 2 is equal to 5 times r, or r would be 2 upon 5. That would be 0.4 meters. So this would be our final answer. Let us go ahead to the next example that is there. Now in this example is from exercise 1a from the chapter Force. This is question number 4. So here we have a diagram where we have 2 forces, F1 which is 5 newtons and F2 which is 3 newtons. F1 is applied at point A, F2 is applied at point B. The distance of A from O, where the fulcrum is or the pivot is 2 meters and the distance of B is 4 meters. So we have to find the moment of force about of F1 about O, moment of force F2 about O, and total moment of force. Now let us first establish what would be the directions of these moment of forces. So for the first force, since it's pushing it downwards, it would produce a anti-clockwise moment of force at point A, and at point B we would be getting a clockwise moment of force because of this second force F2 that is there. Okay, so let us go ahead with the first part. So here what is given to us, so OA is 2 meters, the distance is 2 meters, and the moment of force, here the force is 5 newtons, at point A would be the force multiplied by the distance, giving it as 5 multiplied by 2 or 10 nanometers, and it is in anti-clockwise direction. In the second case, the distance was 4 meters and the force was 3 newtons. So the moment of force would be F2 times OB, so that would be 3 times 4, so that would be 12 Newton meters in the clockwise direction. Now what would be the total moment of force? So since one of the forces is anti-clockwise and the other one is clockwise, their directions are opposite, so we'll have to subtract them. So at point O, the moment of force would be the moment of force in the anti-clockwise direction minus the moment of force in the clockwise direction. So that is 2 Newton meters. Since the larger force was in clockwise direction, my total force would also be in the clockwise direction, which basically means that this rod is going to be pushed in this particular direction. Now let us quickly go ahead with the next example. This is example number 5 from the same exercise. The example tells us that we have 2 forces of magnitude 10 newtons. So 2 forces of magnitude 10 newtons act vertically upward and downward. So we have one acting vertically upward in this direction and one acting vertically downward in this direction. at two ends of a uniform rod of length 4 meters. Now, here it's a misspell. It should be a rod. We have to determine the magnitude of the resultant moment of forces about the pivot O. Now, let us first establish what would be the directions of these moment of forces. So, since this first force is pushing it upwards, it is going to cause a clockwise rotation, and this force is also going to cause a clockwise rotation. So, if you see in both the cases, both the forces F1 and F2, if I can call this as F1 and this as F2, then they are going to produce a clockwise rotation. So, now let's quickly go ahead and check out how we would be getting the final answer. Here we have AB is 4 meters, so OA is half of it, so it would be 2 meters and OB would be 2 meters. So, moment of force because of this force 10 Newton at point at A, about the point O will be the force multiplied by the distance between OA. So, I am calling this as point A and this is point B. So, it would be 10 multiplied by 2, so it would give me 20 Newton meters in clockwise sense. Now, for the second part, again I will do exactly the same thing. Everything would be exactly the same. We would get the moment of force as the force multiplied by the distance OB. So, we'd end up with 10 multiplied by 2, which would be equal to 20 Newton meters. This is also in clockwise direction. Now, in the previous case, one force was in clockwise direction, one force was in anti-clockwise direction. So, they got subtracted. In this case, both the forces are in clockwise direction. So, they are going to get added up. So, the total resultant force would be basically addition of these two, and it would maintain the sense, that is clockwise. So, the total moment of force would be 20 plus 20, that is 40 Newton meters in the clockwise sense. Yeah. So, this is example number 9, which is slightly different because here we see a word draw. Now, we will see how it is different. We have a uniform meter rule balanced horizontally on a knife edge placed at the 58 centimeter mark when a weight of 20 gram force is suspended from one end. Draw the diagram of the arrangement and what is the weight of the rule. These are the two things that we have to find here. Now, here up until now the diagrams were given. In this particular example, the diagram is not given. So, you'd have to imagine what is happening. So, let us imagine what is happening. We have a scale like this. It's a meter rule. So, it would be 100 centimeters long. So, this would be 0 point and this would be point B. So, it would be 100 centimeters. Now, naturally, it would be balanced at the point where it is 50 centimeters. Now, what have we done? We have made it balance at the point 58 centimeters. So, we have shifted the fulcrum towards 58 centimeters. So, this is our actual fulcrum. Now, what can we see from the figure? This length OA is going to be larger than OB. So, OA, since OA is larger than OB, it would produce a anti-clockwise moment. Now, since it is producing an anti-clockwise moment, we would have to add a weight on this at point B so that we can balance this anti-clockwise moment by producing some extra clockwise moment. So, this is 58. I missed out on writing it. Yeah. How much is this mass? Here it is 20 gram force. It is again very crucial to understand. Here the weight is given as gram force and not grams. There is a completely different video which discusses the difference between gram force and gram. The link is given in the comment. You can quickly check it out whenever you get time. So, let us draw a fair figure for this particular example. So, this would be the fair figure. Here we would be drawing a straight line, 100 centimeters. Now our O is at point 58. mg is acting in the anti-clockwise direction like this, and the 20 gram force weight is acting in the clockwise direction. Now let us go ahead and check out the next part that is there. Here we are taking the weight of the scale as W. So in the next part we have to use the principle of moments, which tells us the anti-clockwise moment is equal to the clockwise moment. So we get W multiplied by 58 minus 50. Why? Let's quickly draw the diagram here again. We have point A here, we have point B here, we have point O here, which is at 58. This is 0, this is 100, and this is my 50 mark. So the weight W is acting at this point, making the moment of force in the anti-clockwise direction. And then we have a 20 gram force here, which is making it go in the clockwise direction. Okay, so we have to find the weight. So the force at this point is mg, and it is equal to 58 minus 50. And on the other side we get the clockwise moment. It would be given by 20 multiplied by the distance. So the distance is 100 minus 58, giving us W multiplied by 8 is equal to 20 gram force multiplied by 42, or the final answer would be 105 gram force. So it looked pretty simple once we got the diagram. So again, I'd like to reiterate it. Try to imagine what they're doing, exactly what is happening, and it would make your life a lot easier. Now let us go ahead with the next example. This is example number 10 from exercise 1A. So the diagram shows us a uniform bar supported at the midpoint O. Now a weight of 40 gram force is placed here at the distance 40 centimeters from here and to the left. Now how can we balance the bar with a weight of 80 gram force? Again, here also the weights are given in gram forces, so the final answers would also be in gram forces. So अभी ये वाला वेट 80 ग्राम का है, ये किधर तो इधर अपने को डालना पड़ेगा, इस साइड में, ये साइड में किधर तो डालना है. सो लेट अस सी वी अप्लाइड समवेयर हियर, किधर तो लेट्स हैव अ वेट हियर, ड्रॉ करते इधर ऐसा. सो यहाँ पर मेरा वेट है एंड इट इज 80 ग्राम force. So we have a weight of 80 gram force on this side. Logic बड़ा simple है. This 40 gram force is going to produce an anti-clockwise moment, and this 80 gram force is going to produce a clockwise moment. So in both the cases, these moments need to be equal, and then the final answer we would be able to get the distance. So let us see. The anti-clockwise moment would be 40 gram force multiplied by 40 centimeters. The clockwise moment would be 80 gram force multiplied by the distance d. So we are calling this distance as d. Now we have to say, since by the principle of moments they need to be equal, the clockwise and the anti-clockwise moments are going to be equal, then only they are going to balance it. So we end up with 40 gram force multiplied by 40 is equal to 80 gram force multiplied by d. Or I can say that d is 40 gram force into 40 divided by 80, giving me the final answer as 20 centimeters. So I have to place this block at 20 centimeters and the scale would be balanced. Quickly make a note of this so that we can go ahead. The next example that we have is example number 11. Here I have used figure 1.37. The figure number may vary because I have a different year ka publication with me. So please look for this figure and this particular question in the exercise. It shows a uniform meter rule placed on a fulcrum at its midpoint. So here we have a uniform meter rule, 100 centimeter long rule. It is balanced at the fulcrum. And how is it balanced? it has a weight of 40 gram forces at 10 at the mark of 10 centimeters and 20 gram force at the mark of 90 centimeters. Now, do we know whether it is balanced or not? We don't know it, because they're asking us to find whether the meter scale is in equilibrium. If not, how will the rule turn? This is what they're asking. Now, this is a classic example where they've given the answer embedded in the question itself, because the second part asks us how can the rule be brought in equilibrium. इसका डायरेक्ट मतलब क्या हुआ? The meter rule is not in equilibrium. So एक पार्ट तो अपने को आना चाहिए. We should know, or you should write it right away, that the scale is not in equilibrium. How? अगर आपको मैथमेटिकली कैलकुलेट करने को आ रहा है तो वेरी गुड. अगर नहीं आ रहा, still you will get half a mark for writing that the meter scale is not in equilibrium. Okay. So let us see how the meter scale is not in equilibrium. So you see, if you look at the distances, this distance would be 40 centimeters and this distance would also be 40 centimeters. So they are almost, they are equidistant, the masses are equidistant or the weights are equidistant, and ये वाला weight है वो आधा है, ये वाला weight है वो double है ये वाले weight से. So obviously ये वाला जो moment होगा वो ज़्यादा होगा as compared to this moment. Yes? तो ये तो अपन ने एस्टैब्लिश कर लिया कि मेरा जो दूसरी चीज जो सेकंड चीज उन्होंने पूछी है, व्हाट हाउ वुड इट टर्न, तो ऑब्वियसली इट इज गोइंग टू टर्न इन द एंटी क्लॉकवाइज डायरेक्शन, बिकॉज ये वाला मोमेंट ज्यादा रहेगा, बिकॉज मास ज्यादा है ये वाली साइड में. सो वी एंड अप विथ एंटी क्लॉकवाइज मोमेंट इज इक्वल टू 40 ग्राम फोर्स मल्टीप्लाइड बाय 50 minus 10 centimeters. So it's 50 minus 10 centimeters. So it gives it is equal to 40 gram force multiplied by 40 centimeters. So that would be 1600 gram force multiplied by centimeters, or 1600 gram force centimeters. Now, anti-clockwise moment we have is 20 gram force multiplied by 90 minus 50, giving it equal to 20 gram force multiplied by 40. So it is 80 gram force multiplied by centimeters. So it is 80 gram force centimeters. So we can clearly see that the anti-clockwise force is larger, almost twice as much as the clockwise force. Now they've given us this in the second part. So obviously the rod would move, it is not in equilibrium, and it would move in the anti-clockwise direction. Now how can we bring the rule to equilibrium? By adding 40 gram force. So here we have, from the principle of moments, anti-clockwise moment is equal to clockwise moment. So we end up with 40 gram force multiplied by 40 centimeters should be equal to 20 gram force multiplied by 40 plus 40 multiplied by d centimeters, giving us 1600 minus 80 is equal to 40 gram force multiplied by d centimeters, or d would be equal to 800 gram force divided by 40 gram force. 800 gram force centimeter divided by 40 gram force, which would be equal to 20 centimeters. So effectively we need to add this 40 gram on the 20 centimeters away, that is at this point we should add it like this, so that we can balance the rule. So this was about the question number 11. Let us go ahead with the next example that we have. This is example number 17 from the same exercise 1A. The example doesn't have a diagram given. I have intentionally added this example because it's a pretty lengthy example. However, if you solve it, it's not that difficult to solve. It looks difficult, but when we solve it, actually it is pretty easy once you are able to figure out what the diagram is. So let us see what we have here. We have a uniform meter rule of mass 100 grams is balanced on a fulcrum at a mark 40 centimeters by suspending an unknown mass m at the mark 20 centimeters. Find the value of m, to which side the rule will tilt if the mass m is moved to the mark 10 centimeters. What is the resultant moment now? and how can it be balanced by another mass of 50 grams. तो 4 चीजें हैं. This kind of example generally comes for 4 marks. So first thing first, let us draw a diagram. We have a 100-meter long scale. So let's keep this as 0, point A, this as point B, which is 100 mark. Naturally, it should balance at 50, but it is actually balancing at 40. So we'll call this as point O. Now, we are suspending a mass M on this side. Obviously, it would be suspended here, so it should be at 20. 20 is midway between these 2 points. So we'd put a mass of M suspended here. Now this mass is going to cause an anti-clockwise moment, and then the mass of the scale is going to cause a clockwise moment, because the mass 100 grams is going to act at this point, at the center. So this 100 gram is acting at this point. So now let us see what this mass is and how we can find it. I hope you've understood the figure. Yeah, so we have a mass here at 20 centimeters, and the mass of the scale would be acting at this point, 100 centimeters, 100 gram multiplied by the distance in this direction, giving us a clockwise and an anti-clockwise moment. So let's quickly see. So according to the principle of moments, we have clockwise moment is equal to anti-clockwise moment. So either clockwise moment kitna hai mera? It is 100, the force or the mass that is there, multiplied by 50 minus 40, because it is this much away. Yes, and on this side we have the mass M multiplied by 40 minus 20, giving me 100 gram multiplied by 10 centimeter is equal to M times 20 centimeters. So it would be basically I have to take this 20 on the other side. So I'd end up with 100 multiplied by 10 divided by 20. So this gets cancelled. 1s are 5s are, giving me the final answer as 50 grams, which I got here. Now, the second part they're telling us is, अभी क्या किया इन्होंने? तो we are being smart with this. So इन्होंने इसको ये वाले मास को इधर खींच दिया. Now obviously क्या बढ़ रहा है मेरा डिस्टेंस बढ़ रहा है. तो ये वाला डिस्टेंस बढ़ रहा है मेरा. ये वाला डिस्टेंस बढ़ रहा है. तो ये वाला डिस्टेंस बढ़ रहा है तो क्या होगा? ये वाला मोमेंट मेरा बढ़ेगा. So it would tilt in this side. So point A नीचे चला जाएगा. Okay. So the rule will tilt on the side of the mass M, that is in the anti-clockwise direction. Now if the mass M is moved to 10 centimeter mark. अभी उन्होंने तीसरा वाला क्या पूछा है कि what is the resultant moment now. अभी नया वाला मोमेंट, बिकॉज मोमेंट चेंज हो गया तो रिजल्टेंट कितना आएगा उसका वो देखेंगे. सो एंटी क्लॉकवाइज मोमेंट ऑफ मास एम इज मूव टू मार्क 10 वुड बी सेम थिंग जैसे यहाँ पर था, पर यहाँ पर 50 माइनस यहाँ पर 40 माइनस 20 था. हियर इट वुड बी 50 ग्राम्स multiplied by 40 minus 10. So that would be 50 times 30. So it would be equal to 1500 gram centimeter. Then we have clockwise moment. Clockwise moment कितना होगा? तो जो इतना था इधर था उतना ही होगा. That would be 1000 centimeters, 1000 gram centimeters. तो resultant moment as you've seen ये वाला पार्ट है, ये क्लॉकवाइज, ये एंटी क्लॉकवाइज है और ये क्लॉकवाइज है, तो दोनों को सब्ट्रैक्ट करना पड़ेगा. वी सब्ट्रैक्ट देम एंड वी गेट इट एज 1500 ग्राम सेंटीमीटर माइनस 1000 ग्राम सेंटीमीटर. सो इट वुड बी इक्वल टू 50 ग्राम सेंटीमीटर इन द एंटी क्लॉकवाइज डायरेक्शन. ओके, 500 ग्राम सेंटीमीटर हो गया ये इन दिस डायरेक्शन, इन द एंटी क्लॉकवाइज डायरेक्शन. अभी हमने को फाइनली क्या फाइंड आउट करना है? तो फाइनली वी हैव टू फाइंड आउट हाउ कैन वी बैलेंस by another mass of 50 grams. So, ये 50 ग्राम को कहाँ पे ऐड करना पड़ेगा? Let me change the color in this case. Green ले ले दो. So 50 को मेरे को यहाँ पे कहाँ तो लटकाना पड़ेगा? Somewhere at a distance D from this point तो इस पॉइंट से ये डिस्टेंस d रहेगा. Now obviously it's not up to the scale, so I've just taken a random point and applied the mass there. Okay, so कितना होगा? Let us calculate it quickly. Okay, so we have from the principle of moments, we have clockwise moment is equal to anti-clockwise moment. Now we have to balance the 50 gram weight. So इधर एंटी क्लॉकवाइज मोमेंट तो अपने को पता है क्लॉकवाइज मोमेंट कितना रहेगा. तो क्लॉकवाइज मोमेंट पहले पार्ट का है उतना, वो पार्ट तो ऐड करना पड़ेगा, दैट इज 100 ग्राम मल्टीप्लाइड बाय 50 माइनस 40 प्लस ये जो 50 वाला मास अपन ऐड कर रहे दैट मल्टीप्लाइड बाय द डिस्टेंस d वेयर इट इज kept. So it would give me 50 grams and it should be equal to the anti-clockwise, the new anti-clockwise moment that we've got, which is 50 gram times 40 minus 10 centimeters, giving us 1000 gram centimeter. ये यहाँ से आया plus 50 gram times d is equal to 1500 gram centimeter. Finally, we end up with the distance should be 10 centimeters. So कहाँ से 10 centimeters? मेरे fulcrum से 10 centimeters. Yes. तो कौन सी वाली साइड में? दूसरी वाली साइड में. ओके, सो ऑब्वियसली कौन सा मार्क आएगा? तो 50 सेंटीमीटर का मार्क आएगा. कैसे आएगा वो? यहाँ पर देखते हैं अपन. तो ये मेरा 40 सेंटीमीटर था, तो यहाँ से 10 सेंटीमीटर ऑन दिस डायरेक्शन. तो ये कहाँ पे आ गया? 10 सेंटीमीटर ऑन दिस डायरेक्शन. तो ये यहाँ पे आ गया. तो मेरे को यहाँ पे और ये जो है यहाँ पर और मेरे को प्लस 50 ग्राम डालना पड़ेगा एंड देन द स्केल वुड बी बैलेंस्ड. So quickly make a note of this. So first make a note of this. Then make a note of this as well. So learners, these were the examples from the chapter force. If you have any other queries apart from these examples, please comment the question number or you can just type in the question in the comment box. I would gladly help you out. If you found this video interesting, please give it a thumbs up, share it with your friends and subscribe to our channel. This was Dr. Rishi from the Learners Academy. Thank you.